So, two things you have to know to use the each interior formula. One is that it says each, or some version of that. What's the other important thing to know? Regular. Yeah, so we need to know that all the angles are the same. That's what that's telling us. So then we need to write the equation. And just as a reminder, the front page, kind of halfway down, is all of our angles for polygons. That's our formulas. We have 4 of them. 2 for interior, 2 for exterior, and obviously this is interior angles. It says the word to kind of, tell you at least which 2 to narrow it down to. And then it says each interior, it also says regular, so it's kind of pointing us towards that second equation. So, let's get the same color. That's good. What does this top part tell us? 180 times n minus 2 gives what?
The amount of
Total degrees.
Total degrees in the figure. Yep. And then we divide that evenly over the n different angles that we have. So in this case, a 100 gone. So we know n is 100. Okay. That means we can plug that in. So 180 times 100 minus 2. And also 100 on the bottom. And then it says it's 3x plus 24, the measure of each. So that weird looking expression gets plugged in on the left side. And then we just solve for x. So what's a good first step? By the way, at this point we're done with the polygon stuff and we're just doing algebra. So what would you do first? Okay, sure, I could do that. Minus 360. Did you have to do it that way? No. In fact, I'll show you another way that you might, and maybe somebody did it, but that you might think is easier. Let's see. Okay, what's next? Yeah, sure. So if I multiply both sides by 100 to get rid of the denominator, the thing is on the left, if I just write it here like this, I'm only multiplying 3x by 100, and that's not okay. So make sure to put parentheses around that left side, the whole thing. Okay. Anyway, these hundreds cancel over there, so that's nice. You could also combine those, right? It's just a subtraction, so that's an option. And there was that next line. Now what? I would go ahead and combine the right side. And let's kind of do it all at once. So we only have to go to the calculator once. So subtract 2640 from that side. And also this side. So here's what I'm saying, like I just have to punch this all in at the same time now. Which I know if you have your calculator sitting there is nice. This one, since I have to flash back and forth, it's kind of annoying. So try to do it all at the same time. And we get 15,000. Okay, and then just divide by 300. So what is x? No, not that. Sorry. Let's see, those cancel. 150 divided by 3 is 50. Okay. How'd that go? A little easier way to do this, I think, if you look right here, this is 180 times something, so it's okay to just divide right there. Now, I say it's easier because the numbers are smaller, but they're, let me just write out what you would get. So over here you would get 1.8 times, let's just do 98 right there. Okay, so 180 divided by 100 is 1.8 times 100 minus 2. And that gets rid of this fraction already, and it also gets rid of having to distribute all in one step. So it's a little less work. I don't know if you like having the 1.8 times 98, but can you see that color in the back, the green? Yeah, let me do that again. I was looking at it from over here, and it's really not very good. So our right side is the same. Okay. So do you see how this, just that one step of dividing there, takes us all the way to this step, and it skips a couple, which is kind of nice. So I don't know, do you think it looks easier? I mean, 1.8 times 98 is just a number, so no. So 176.4. And then subtract off the 26.4. Do you see where this is going? Okay, so subtract 26.4 and then you're at 150. So you're 100 times smaller than you are down here. Which, it's the same exact result. We get x equals 50. So either way, that's fine. Just know that you have options. Did anybody happen to do it that way? Good, nice. Any questions on this before we check our kite work? Okay, grab that. Okay, so number 20 is 63. Sorry, that's 23. Jump up. Here we go. 105.5 for 20. 21 is 90 for 1. 25 for 2. 22 is 118. Those are congruent because they're on the short diagonal. Do we have to have a short diagonal to see that it's the short side? No, you know. 23 is 60. Well, angle 1 is 90. Angle 2 is 63, which is the same as angle 3. Angles 2 and 3 are both 63. 24. Angles 1 and 2 are both 107. 25. Angle 1. Where is angle 1? 90. I just put it there. Angle 2 is 39. Angle 2 is 51. Angle 3 is 39. How's it going so far? There we go. 26 should be 8 instead of 7. It should be 8. 27, x is 7. 28, x is 28, and y is 32. And then 29, x is 4, x is 4, either way you do it. 30, x is 14. Any of those you'd like to do? $25, okay. Is anybody planning to be a software developer? Because I sure would like you to redo the scroll bar for Adobe. You can't see it. You see how faint that is?
Mm-hmm.
I don't get it. Alright, there's 25. Let's go ahead and check that one. Angle 1, I put the 90 on the right, but because anytime two lines intersect, if one is 90, tell me about the others. They all have to be, right? If you think about vertical angles, so those are both 90. And then linear pair, here, if one is 90, the other has to be 90, and then we have vertical angles the other way. So anytime two lines intersect and make a 90, all four angles are 90. So angle 1 is 90. Angle, this, put a dot here, that angle right there is 51. So we're looking at 51, 90, and angle 3. How do we find angle 3? Yeah. So measure of angle 3, 180 minus 51 minus 90. And angle 2 is the same as 51. Why? But how do we know? You're right, they are, but how do we know? On the picture? There isn't one.
Yeah, there is.
Not for the angles. Because in a kite, what's true about these two angles? Those are opposites, right, first of all, and they are on the shorter diagonal, so they are the two that are congruent. Remember, we only have one pair, it's those two. Even in this picture, does it look like I should mark this as congruent? Are those two congruent? No, I mean, this angle here it doesn't even look the same as that angle, right? Not that we just go based on looks, but it confirms that it's not. But in this case, those two do look to be the same. So it's okay to use your eyes to kind of guide you to a theorem or a property. Just don't solely rely on looking at a picture. Okay? Does that help? Any others you'd like to do?
26.
Okay. I'll try to squeeze it on actually. Paste. Oh, I hit copy. Darn. What happened? I see two of the same thing. Oh, I'll just start over. Promise I'm gonna get there. That was more hassle for some reason. Alright, first we identify the shape, which is a kite, and of course all of these were, but that's gonna be a thing as we get more into the shapes. Identify which shape it is first. And then you start picking properties. Well, when I look at this, I know we're talking about angles, because all three arrows are pointing at angles. So we have three properties talking about angles. One was that the middle is 90, where the diagonals intersect. 2, these are congruent and those are congruent. There we go. And opposite angles on the short diagonal are congruent. So there's our three properties. Well, what of those helps in this case? I definitely need this 90, okay? And I'm going to go ahead and delete those marks just because it gets kind of busy. And then we'll use that in a second to get that over there. But let's look at this triangle right here. And zoom in on it. So we wrote in our notes, redraw. Because what kind of triangle is that? Right. It's right. We know that because of that, I think it was property 4, tells us that that's 90. So I would just write an equation like this. What does that have to add up to? 180. Notice that you also could set these two equal to 90 if you want, because the first step could be to do this, right? Either of these, either the red version or the purple version, they are the same, okay? Huh. What you got there? Good. Good stuff.
Yeah.
Thank you.
You're welcome.
Everybody see what I'm talking about? Okay. Anyway, from here we can just combine our like terms, which is just the x's, so 12x minus 6. Can I go ahead and put that over there? 96 over there. Are we good on that? Are you good on that? Alright, so x is 8. Should that help? I like these, and maybe you hate me for it, but I like these problems that have extra information that you don't need. Oh, goodness. Why would I like them? Besides the fact that it bothers Noah. Because what?
Because you like things to be
Oh. I don't mind easy things.
like watching a movie.
True. Because does life just hand you the exact stuff you need and you're just like, oh, put it together and my problems are solved? No. So I think it's more realistic when you have extra information you have to sift through and know which to use. So that's just my opinion. Any others?
28.
8?
28.
Yeah, 28. Oh yeah, I was hoping someone would ask about this one because it's good. Alright, so again, this time I have 2 variables to solve for. And part of me screen grabbing that one was I have a y there. How do we know that that's y? Because it wasn't given that way. How do we know it's y? See if you can find which property it is in your type properties. How many of you studied them last night? No? You guys, I'm telling you. It's not 1. I'm just gonna go through that. It's not that one. Okay, so I'm gonna
3.
just remind you what I'm saying. If this is y, that's y, which means I could put that mark there because they're both the same. So which property is that? That's 5, right? The long diagonal bisects the angles. Okay, I mean I could do this as well, and so you could write y minus 9 right there. Either way. Okay? And now we're ready to solve because we used that property. Do you see it? Okay? Again, either way, you should be seeing a triangle with now 3 pieces, 3 angles named at least, with 1 variable. Actually, I said that wrong. We'll use that in a second. Right now, we need to use this and that. Which property is that? Property 3. Opposite, there's exactly 1 pair of opposite angles that are congruent, and they are on the short diagonal. But, Mr. Atkinson, I don't have a short diagonal in this. Is that an issue? Can you just draw it? You really can, right? It's totally fine. Okay? So that means we can set the 2x expressions equal. Hopefully at this point in the class, you know that we don't just see stuff that looks like it should go together and set it equal, because you get burned that way, right? You always need to know if that's okay to do. All right, solving, we get 28 for x, right? So subtract 4x and 15, and then x is 28. All right, so with x being 28, now we can use the blue triangle. And we have y minus 9. This is, I always like to keep reminding you what we wrote in the notes. This is where we wrote, sorry, it was on this page. Redraw. That's why we wrote this. Okay? So I'm redrawing just that little piece so we can zoom in on it. How big is this bottom angle? If x is 28, how big is this bottom angle? Because you don't want to stick x back in here, because now we're dealing with y. 140 minus 15, so 125. Okay, how do you solve that for y? While you're thinking, I'm just going to write this in here. How are we going to solve for y? To what?
To 180.
Why?
Because the triangle is equal to 180 degrees, and so you're just adding them all together and solving.
Yes, you got it. That's exactly what we're going to do. What is that? 64? Okay. How many times, even in this short time we've been in this unit, have we seen a figure and then ended up working in a triangle? It's a whole bunch, right? Now, I don't want you to take that and go like, well, every time we do this, it's a triangle, because it's not always. But often it is. So keep your eyes peeled for those, right? Even if a diagonal is not drawn, you might need to draw it to create a triangle. How do you feel like kites are going? There, give me a thumb somewhere. Okay, we're all over the place on kites. Tell me the difficulties that you're running into. Like, what are you finding difficult about kites? Okay. What else? She said figuring out what procedure to use. Yeah? Alright, why don't you grab your notes? I want to give you kind of a... It's a pretty general process, but it might help. I'm going to put it at the top of this page because this is where you're always going to reference your properties for the whole unit. And hopefully it'll catch your eye and you can avoid some pitfalls. So step one, I'm going to say carefully before I get that word. Carefully identify which quadrilateral that you're solving. Right now, all we have information about is kites, so it's easy because I can't really give you stuff about other figures. But by the end of the unit and by the quiz, this will be a huge step. Like critical, I mean, not difficult, but really critical step. You've got to know which one of these it is, okay? And if you look at the parallelogram tree, they're all parallelograms. Some are more specific. So is it in that side, is it just a parallelogram or is it a rhombus? And those have slightly different properties, okay? So that's huge. Number 2, identify, and we've already written this part a little bit, which property or t's apply. And I'm going to give you 2 questions. Well, it's sort of just one question. Is it angles? Is it sides? Okay, we're going to practice this for a second. Look at the kite properties, and don't shout this out, just have an answer in mind. I want you to tell me the property numbers that are angles and the property numbers that are side length. She labeled hers yesterday, by the way. That seemed like a good idea. Sides or angles, property 1.
Sides.
Sides. 2, sides or angles?
Sides.
Sides, or lengths, we could say. 3, sides or angles?
Angles.
Angles. 4,
Angles.
angles. It is angles, but this also helps us solve sides because it creates right triangles. In fact, you know what? While we're here, let's think about that. Write this down so it kind of helps keep giving you hints. This creates right triangles to use a squared plus b squared equals c squared. We're going to make a cool shape with our bubble. Just a little hint, just a little reminder. This is creating right triangles. So yes, it makes the 90 in the middle, and we've seen that that's important for solving for angles, but also for sides. And how about property 5? Sides or angles?
Angles.
That's angles, right? That creates congruent angles. So that's what I mean by identifying which properties apply. The ones that you guys were just asking about were all angle problems. So we were either using 3, 4, or 5, or maybe a combination of them. Okay? All right, number 3. We've said this a lot this year. Write a true equation using those properties. Why? So, like I said, we've written this kind of an idea a lot this year. Why am I always saying write a true equation? Why is that word true in there? What do I mean by that? Mm-hmm.
Making sure it makes sense.
Okay, yeah, making sure it makes sense. Like, don't add your side lengths up to 180. Because that doesn't make sense, right? What adds up to 180?
Angles.
Angles in a triangle. Okay? And then 4 is just solve with our strategies. No, you oughta like this. You're always drawing like bubble stuff on your thing. Alright, let's kind of think through this as a strategy. And for that, just quickly bounce back to this problem. And the scroll bar is gone. There we go. Okay, so we look at the shape. We know it's a kite because we have been working on kites. And then we identified properties. In this case, what property gave me the ability to write these two pink congruent marks? Which property? 5. What property allowed me to write these red marks? 3. Why am I even looking at properties 5 and 3? Because which are we solving for? Sides or angles? Angles. So do you see how angles tells us which property to look at versus sides telling us a different property? Okay. This process will become more clear as we get more of these shapes filled out. Okay? Are you ready to move on to trapezoids? And then practice those? I guess before you answer me, you'll have a quiz on the polygon angles, kites, and trapezoids. So I'm thinking probably next Tuesday, but we'll see. I mean, I don't want it to be much later than that, probably. At least then, is what I'm saying. So I'll give you a review on this. I'll give you another practice on kites and trapezoids if you need it. Are you ready to do trapezoids today or not?
No.
No. So kites it is. Sure? Okay. All right. So do those, and there we go. And number 4. I don't know how to say his name. I'm going to say Iman. Says every kite is composed of 4 right triangles. Is he correct? Yes. Explain. Why is it always 4 right triangles?
It's bisected by a long diagonal curve.
And these diagonals are always perpendicular, right? That's a property of a kite. Those diagonals are perpendicular. So if we draw them in, then we have 4 triangles. They're always right triangles. All right, next one. Use this kite to find the measures. What's the measure of x, q, y? That is right there. What's the measure of it?
90.
Measure of angle YZQ is right here.
12. 34.
What was it? Okay, but let's show Y. That's 90. Right now, that's all we know in that triangle. So we need to get some more information in there. And notice, guys, a lot of times I'm redrawing and focusing on the piece, right? Do that. Put that into your workflow. Anyway, we need some more information in there. Like what?
12.
12 is the side length right here. That's 12.
56.
That 56 is in the left triangle. Is it okay to put it in this one? How come? Those are congruent, right? Which makes the 56 congruent as well. Alright, anyway, 90 plus 56, and then subtract that from 180. So we get 34 degrees. Are you sure it's not 24?
Yeah.
It should be 24, right? Because 1, it's 34.
It is.
There we go. Alright, WY. That's this whole length, and it tells us this O or QY is 12. So 24, how come? Tell me the property number on our notes.
2.
Property 2, yep. Diagonals well, the long diagonal bisects the short one, or exactly one diagonal is bisected and it's the short one. However you want to say that. Alright, so here's your instructions for this sheet that I handed out just now. Huh? Yeah. Because half of it is 12, right? In other words, this is kind of what we're zooming in on. This is 12 and those two pieces are congruent, so that's also 12. And this is W, Y. Good? Anyway, I don't want to give you any hints. I just want you to do the kite problems on the paper. Okay? So you're going to practice step 1, which is identify the shape. And the rest of the steps too.